You want to first clearly outline what are all the possible events here. What could possibly happen with this gambling game? So go ahead and pause and read through the word problem if you haven't. But there's basically three events. There's three things that can happen. We could win. Oh, I guess I can't draw. There we go. We could win. We could lose money, or we could break even. Right. So if you read through it, we're placing a $5 bet. There's one number where we could win. There's one number where we could lose, and then every other number is just $0. So that, since there's a bunch of zeros here, that means calculating the expected value should be easy because a bunch of things are going to be multiplied by 0. Okay, so they're placing a $5 bet, and the word problem says that you get your $5 back if you hit any other number other than the ones they specify. The probability of winning is 5/6. So when we calculate an expected value, we take a probability. Sorry, it's 5/36. We take the probability and multiply it by the value. They said that we win $6 if we win. Okay. So the probability of winning is 5/6, and if we win, we get $6. And we get to keep our initial bet. So the $5 comes back to us. We don't have to worry about subtracting 5 or anything like that. Basically, there's a 5 out of 36 chance of getting $6 for the winning part. And then losing is 1/6. And if you lose the $5, it says it gets taken away from you, the $5 initial bet. So there's a 1/6 probability of losing money. And then we multiply that by -5 because we're losing $5. And then it says anything other than those two possibilities, winning or losing, you break even. So you could calculate the probability of everything else, which it all has to add up to 100%, but it doesn't matter because we're multiplying by 0, right? Okay, so let's take out our calculator to take care of those fractions. We can do 5 divide 36 times 6. That's 0.83 repeating. And then over here we have 1 divide 6 times -5. That's -0.83 repeating. And then plus whatever this probability is, we got lazy. I got lazy. I never calculated because it's times 0. Look, the whole thing balances out. You add those two together and you get 0. So what's the expected value on rolling in this game? It's 0. You expect, if you were to do this again and again, over and over, you'd expect to come out with $0 over time.